Gravity Part 2, Episode 2. So, back to the wave. I have a ball, weighted ball. And this time, instead of the wave, I want you to think of a 3D oval. Kind of like this. Now, I want you to have an infinitesimal, or these line segments that go through it, and there's a whole bunch of them. So you just got line after line after line. We'll call this an infinitesimal. It means very small. Or what? An infinitesimal line segment. Or and I want you to picture them kind of like the wave, but they're blankets. So you place the wall in, and you have this one line goes through, and where the ball is, it drops. Right there. Right? So now I can say that I have this curve that goes down. I have a little circle, a little circle, circle, a little circle, circle. So now I have all these little circles going up through this thing that looks like a vortex, kind of like the water. So you take away the hammock, and now you picture something blue. You have a yellow ball. So, little yellow ball. By the way, we call these little circles a derivative. So you have this ball right here, and this ball is in this like blue line. Everything around it is like blue. So you have like this blue line. We'll go ahead and draw one main. Go ahead and draw one. I'll go and do this. So you have pretty much that right up there. So what I can say is that this blue line represents space, or the water. And just like with the water, space moves around my ball just like in the water. So if we picture this as water, and now or a hammock, or like a blanket or something, and this time what we're gonna do is we're gonna picture water. So we're gonna picture the water, but instead you'll have an end that curves back around and kind of kind of create something like this. Well, I have the ball inside of it. Now what can we say about water? Water has volume, which means it has an infinitesimal number of line segments in a 3D space. So infinitesimal line segments in pretty much every direction in an object with depth, size, or an object with space. So a cube for this cube, that's 3D. So I have an infinitesimal, a number of lines that are really small in the volume. So I could say that I have a line multiplied by an infinitesimal in a 3D shape. So that means that you would have picture more like waves going. Picture the lines as multiple waves, except these waves are straight, and as soon as they get near the ball, they bend. And you put the ball in, and this time, instead of the ball dropping, it is now floating. So, something like this, I can say, what I want you to do now is I want you to create a whole bunch of vortexes created by the water. Except this time, don't make them like just have 4. This is what the bend in space-time pretty much looks like. So I can say that these little bends in space-time, or the water, the vortexes, is what space-time looks like. And as I stated before, space-time the universe has negative mass and we have positive mass. So the ball has positive mass and the universe has negative mass. And if F truly does equal mass times acceleration, well then mass is a force. So I have a positive force of mass and a negative force of mass. So why does any of this matter? Well, because if you look at the vortex and you think about it, you can picture that the reason why the ball was floating is because the positive mass. So at first, it's pulling in. So it has these lines pulling in. And the negative mass is lines pushing out. The reason for this is because at the moment of implosion, we have something called density, represented by a P, and we call this critical density. So it becomes so dense that it reverses its force of mass. And the bend in space-time, we call that, in the first one it would be linear strain, so pressure causing linear strain. And in the second representation, it would have been volume strain. So the pressure creating volume strain. So how does any of this happen? Or, well, how does the strain even happen? Well, the reason why objects don't just fall is because of the negative mass pushing out. That pushes on the positive mass, keeping it in place, while the positive mass pushes in on itself, bringing things towards it. So if the positive mass is bringing things towards it, how does it bend that it would have to push out? So whenever we put something, the reason for gravity is because it's something and nothing. So it's the opposite of nothing. Or the opposite of something. So we have positive mass, that's the opposite of negative mass. So whenever I put positive mass and negative mass, they both change, or delta, to now the positive mass is pushing out and the negative mass is pulling in. But it's not just a change, I have a change here too. So I have, while the positive mass is pulling in, it's also it's pulling in on positive mass while pushing out on the negative mass, and the negative mass is pushing out on the positive mass and pulling in the negative mass. So this is a release in pressure or density. This is an increase. This is an increase in density or pressure, and this is a decrease. So they're tied with each other and tied with the opposites, which then tie with each other, and then oppose the opposite. So it's like this one. It's like, okay, so this one works with this one. This one works with this one. This one opposes this one, while this one works with this one, while this one opposes this one. Wait, no, while this one works with this one. And then back, and then back, and then this one opposes that one. It's a whole bunch of series that are happening. So I can say that the So I can say that the volume pressure of negative mass equals the change in gravitational force of the change in gravitational force. So